Hello students, welcome back to online classes. Standard 8 subject maths. So today we are going to start new chapter number 7. Cubes and cube roots. So what is the meaning of cube numbers? Numbers obtained when a number is multiplied by itself 3 times are known as a cube numbers. For example, 3. When you are multiplying same number 3 times, then whatever number you are getting after multiplication, that is a cube numbers. So 3 times you will multiply 3. 3 3s are 9. 9 3s are 27. So 27 is a cube number. Same way you multiply 2 3 times. The number 2 3 times, then you will get 8. That is a cube number. Now, cubes of numbers from 1 to 10. Here in this table it is given cube of 1, 1, cube of 2, 8, cube of 3, 27, cube of 4, 64. And here number from 5 to 10, answer is not given. That is in homework. You have to find out the cubes of these numbers. Okay. Then here 11 to 28 is given. You can practice it. From number 1 to 10, cube of these numbers you must have to learn. You must have to remember it. Now if you want to see that given number is a perfect cube or not, then what we have to do? Here you have to follow the same method as we are doing in the previous lesson, that is a square and square root. First of all, you have to find out prime factors of this given number by prime factorization method. What is the number? 216. So you know how to find the prime factors. So here all these prime factors are given. These prime factors you have to write here in the form of multiplication. And you have to make a pair of these factors, that each factor appears 3 times. You must have to see each factor appears 3 times. Here in a factor number 2 and number 3 is given. Both the factor appears 3 times. It means this 2, that is also 3 times, and 3, that is also 3 times. Okay. When this factors appears in a group in triples, that factors grouped in a triples, it means 3 times, then this can be a perfect cube. Okay. See, this example number 1 is 243 a perfect cube. So here prime factors are given. So in this factorization you can see first pair is completed. In a second pair 3 into 3, that remains after grouping the 3's in a triples. So you have to group this factors in a triples. If it is incomplete, then that given number is not a perfect square. Exercise 7.1. Question number 1. Which of the following numbers are not perfect cubes? First one, 216, that we have already seen just now only. Second one, 128. First of all, find out the prime factors. Here is the prime factor. Okay. Now write down all the prime factors in a multiplication form. Now make the pair. Which factor do not appear in a 3's group? So first, all the factors are same. 2 only it is given. Make the group first and the second. Third one left out, which is not in a group. So here you can see one factor 2 that does not appear in a 3's group. That's why given number is not a perfect cube. Next, 1000. Prime factors are given here. Make a group. So all factors appear in a 3's group. So it is a perfect cube. Then 100. Prime factorization. Okay. Now see the prime factors. All the factors do not appear in 3's group. 2 and 5. Okay. that appear in a 2's group. So given number is not a perfect square. Here also prime factorization method. Follow. Find out the prime factors and check the group. First 3. This is the second group, third group, and this is the fourth group. Okay, all factors appear in a 3's group. That's why given number is a perfect cube. Question number 2. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. Here also same method. First number 243. Find out the prime factors. Okay, here prime factors are written. Now find out which factor does not appear in a 3's group. So first group, here it is and this is the second group. So in a second group 3 does not appear in 3's group. Here it is only 2 times, but we want to make it a 3's group. So that's why 243 must be multiplied by 3 to make it a perfect cube. Second one 256. Here are prime factors. This is the first one, second group and third group. So 2 groups completed. In a third group only one factor 2 is required to make a 3's group. That's why this number must be multiplied by 2. 72. Here 72 is given. Here are the prime factors. First group, second group. First group is completed. In a second group 3 does not appear in a 3's group. So given number must be multiplied by 3. 675. Here prime factors. First group completed. Second group 5 into 5. So 5 does not appear in a 3's group. So given number you have to multiply it by 3 to make it a perfect square. 100. Okay, here are the prime factors. So here in a first and second group factor 2 and 5 both do not appear in 3's group. Here are first group also and in second group also. Okay, so 1000 must be multiplied by 2 and 5. You have to multiply this 100, not 1000. First you have to multiply by 2, that is a 100 into 2. So you will get 200. Next 200 into 5. So you will get 1000. So instead of multiplying 2 times, directly you can multiply whatever missing factors are there. First you multiply internally. So 2 5s are 10, and then after this multiplication, that you have to multiply with the given number. So 100 must be multiplied by 10 to make it a perfect square. So here up to question number 2 we are completing. Remaining questions we will see in the next lecture. Thank you.